to finish 1.4. Again. Okay, first question. Quick review. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Can you tell me, of the 6 trig functions, which ones are positive in quadrant 1? All of them. What about quadrant 2? Sine. And we will put cosecant under there. What about quadrant 3? Tangent and cotangent. And what about 4? Cosine and secant. So all students take calculus. That is when they're positive in those quadrants. Okay? That will become very helpful very soon. We talked about a lot of stuff yesterday, but I'm going to ask, can you find, if I give you one trig function, sine theta is 2/3, and theta is in quadrant 2. Can you find the remaining trig functions? So we're going to start today. I'm going to show you 2 different ways to find this answer. Okay? You need to know both ways. Okay? But there will be times that I say use this specific way. So that's why you need to know both ways. So we know we're in quadrant 2. Correct? So quadrant 2, what do you know about your x, your y, your r? Which ones of those do you know? What do we have? I mean, even go sinus, opposite over hypotenuse. So the opposite is 2. Your y value is 2. And your r is 3. Can you find your x value? Yes, you can. How are you going to go about doing that? We're going to use the Pythagorean theorem. I'm going to erase so I can write other places. So using the Pythagorean theorem, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. So we should have something like 9 minus 4. Rearrange and solve, and you get something like negative. Why is x negative? It's on the x-axis going left. And we get the square root of 5. So now we have our x, our y, and our r. Can we find the other 5 trig functions? You know sine, well, what is cosine? Cosine theta. Adjacent over hypotenuse, and you get negative square root of 5 over 3. What about tangent theta? Opposite over adjacent. 2 divided by negative square root of 5. Oh, wait, we can't leave it that way. We still have to rationalize. So we are left with what? Negative 2 and square root of 5 over 5. Let's keep going. So we have cosecant theta. Pretty simple. We're just flipping sign. Correct? 3 over 2. What about secant? So we're rationalizing negative 3 on the square root of 5 over 5. And then cotangent. Okay, we don't have to worry about that one. Negative square root of 5 over 2. Could we have said, and not really even worried about this negative sign with x? Because sometimes you're going to forget it. I'm just going to tell you. You might forget it. The biggest thing that I grade mistakes is negative signs. You forgot negative signs, and I put negative and I circle it. Okay? If we know sine is positive, we're in quadrant 2. That means everything else except for cosecant is going to be negative. So you can go ahead and put all your negative signs there. Okay? Wonderful way to solve this. Plot it, draw your triangle. Okay? Could we possibly do this without drawing a triangle and making a graph? Yes, we could. Probably so. A lot of times I actually like this way, but there's another way to do it that will be useful at times. Okay, I'm going to go ahead and switch. And we're going to talk about Pythagorean identities. Identities. What did we just talk about? The Pythagorean identity, or the Pythagorean theorem. Can I use x's and y's and r's? X squared plus y squared equals r squared. We all agree that's a true statement, yes? Now, if I want something to be true, okay, general mathematical equation. If you do something to one side, you do it to the other, and that's still an equal sign, an equivalent equation, correct? So we're going to do three different things to this equation to make our Pythagorean identities. We're going to start, and we're going to divide everything by r squared. If you divide one thing by r squared, you have to divide everything by r squared. Ultimately, we want a 1 in there. Can I ask you a general generic algebra question? X squared divided by r squared, could I rewrite it as x divided by r squared? Does that work mathematically? Yes. So if I have x divided by r squared plus y divided by r squared, and then r squared divided by r squared is simply 1. Okay? Well, what is x divided by r? What is x divided by r? I told you we were kind of going to talk about these. If you have this, and this is r, this is x, this is y, x divided by r is cosine. So I can rewrite x over r as cosine theta. Okay? I'm going to give you a hint. They put the squared before they put the theta. It's not cosine theta squared. It's really, I'm going to tell you, it actually means cosine theta parentheses squared. Okay, that's what it means. They are always going to write the squared after cosine. Cosine squared. Okay, but this is what it means. Well, what is y over r? Sine squared theta equals 1. Have you heard that? Have you seen that before? So let's pick a number, any number. 5. Okay, so we're going to do cosine squared of 5 degrees plus sine squared of 5 degrees equals question mark. So you're going to plug in your calculator. I'm going to do parentheses. Actually, I have to turn it on first. Cosine 5, parentheses, in parentheses, squared. Somebody needs a calculator, don't they? Plus parentheses, sine 5 degrees, in parentheses, squared. You have to put them before, because right now you're squaring 5. That's why I have to have parentheses. So I'm going to do this in my calculator. Cosine 5 in parentheses squared. That's how I'm plugging it in my calculator. Yes. Hit enter. What'd you get? 1. Let's try 47. Instead of 5, put in a 47. I think those calculators, you can just go and copy that whole thing and not type it in there. got 1 again? Try negative 78. Try negative. Does everybody know where their negative button is? It's the one beside enter the little parentheses. You need a calculator. Oh, you're just plugged in. There you go.
Guess what?
Guess what? It's 1. It's a Pythagorean identity.
What if you did like 4,000?
What do you mean? Sign it. We're going.
Okay.
So your first Pythagorean identity, I don't know why, it always comes out to cosine plus sine. I always say sine squared plus cosine squared. I don't think it matters. Do you know why it doesn't matter? The commutative property of addition. Oh my goodness, go back to 7th grade all of a sudden.
Did you know if you did 4,625?
As long as your thetas are the same, it will always work out. It's kind of crazy. All right, so I'm going to erase, and we're going to try to fit all of this on one page. Okay, so there was our example. Let's do another one. So we're still going to take our same equation, x squared plus y squared equals r squared. So don't divide by r again. Let's divide by y. So let's divide by y squared. If you were to divide by y squared, we have x over y squared plus y squared over y squared, which is 1. And then we're going to r over y squared. Now, this one takes a little bit more thought.
Yeah, I feel like subtract the x minus y squared.
No. Let's leave. So our x and our y and our r. So what is x over y? X over y, looking at this diagram, it's a tangent, but it's a cotangent. I'm thinking opposite over adjacent, but it's the opposite or reciprocal of that. So this is really cotangent squared theta. Okay? Plus 1 equals, now what is r over y? Y over r is sine. So r over y, the reciprocal of sine is cosecant. So we have our second Pythagorean identity. Let's see if I'm going to make it up there. Yes, I'm not going to automatically put this one in my calculator because it's reciprocals of both, but it would work. I promise, it would work. And I'm going to talk about this in just a minute. I'm going to do it right now. All right, and lastly, if we take this equation, x squared plus y squared equals r squared, and divide, the only thing we haven't divided by is x. So if we divide it by x squared, what are we left with? X squared over x squared is 1. Y over x squared and r over x squared. So what is your y over x? Y over x is opposite over adjacent, which is tangent. So we have 1 plus tangent squared theta equals, now r over x over r is cosine. So the reciprocal of cosine is secant squared theta. We have all 3 of our Pythagorean identities. Maybe you notice that there are 2 trig functions that are squared in each one of these. They're all used at some point in time. We've got 2, sine and cosine, cotangent, cosecant, tangent, and secant, all put in here, okay? Eventually, I will allow you to write these down somewhere. We'll work on that later, okay? Because one I remember is cosine plus sine equals 1. The most used, it'll show up on the ACT. It's a great thing to know. Okay? Sine squared plus cosine squared equals 1. Now, question mark. Well, let me give you one other thing. I actually do remember one thing. My C's go together. The one time the C's go together. Once I have sine and cosine out, bless you. Cotangent, cosecant, I know they go together. And then tangent, secant, they're just the oddballs and they're over there together. Okay, so if I have to remember them, that's how I remember the C's go together, but they're on opposite sides of the equal sign. Okay? But, could I rearrange? Okay? You know how to rearrange things, correct? Yes. So if I wanted to rearrange cosine squared plus sine squared equals 1, I wanted to rearrange to equal sine squared. Could you rearrange pretty simply what sine squared equals? What are we subtracting? So it's really 1 minus cosine squared theta. Or I could rearrange and solve cosine squared theta. It's 1 minus sine squared theta. So just knowing these, we can have lots of different formulas just rearranging. Eventually that's going to be very helpful. Could I rearrange and solve for cotangent squared? I bet I could. What would it be? Cosecant squared theta minus 1. I mean, technically we've already solved for cosecant, so I don't really need to. What about this one? Could I solve for tangent squared? This is going to be secant squared minus 1. So be able to rearrange, manipulate, solve for other things. Okay. I told you earlier that we would learn 2 different ways. So I'm going to give you kind of the same problem, but ask you to use identities to solve these things. Okay? So if I were to give you sine theta equals 2/3. So sine theta equals 2/3, and theta is in quadrant 2. Again. But this time I want you to solve using a Pythagorean identity. You're given sine. Can you find cosine by plugging it into the formula? If you have the formula that says sine squared theta plus cosine squared theta equals 1, if you have sine theta, which is 2/3, we're going to square it. Because it's sine theta squared. So we know sine theta is 2/3. We're going to square it plus cosine squared theta equals 1. And if you've had Dr. Hearns for physics, she's going to say rearrange it first. So she would say rearrange and have cosine squared equal to 1 minus sine squared. So she would rearrange first. I generally don't, but you can. So you're solving for cosine theta. And we'll go ahead and say 1 minus. Everybody know that 2/3 squared is 4/9. Do we all agree with that? Yes. So what is 1 minus 4/9? 5/9. So that's cosine squared theta. So close. If I know what cosine squared is, well then what is cosine? So the square root of such. So what is the square root of cosine squared? Cosine theta. What is the square root of 5/9? Oh, I probably also need to bring up. When you take square roots, what's something important you need to do and know? What's the square root of 9? 3. Is there anything else it could be?
Oh, no. Wait, yes.
-3. Because 3 times 3 is 9, but -3 times -3 is also keep that in your brain because ultimately this is a plus or minus. Now, you're not going to leave it as plus or minus because you know what quadrant it's in. So you have to make a decision on what quadrant is it in. Is it going to be positive or is it going to be negative? Okay, so let's keep going. Cosine theta is quadrant 2, the negative. Do you know how to pull these apart?
Yes.
Square roots, if they're multiplied, you can pull them apart. If they're divided, you can pull them apart. So this really is the square root of 5 over the square root of 9. Okay? So do you know the square root of 5? No, you do not. Do you know the square root of 9? Great. Is that the exact answer we got earlier for cosine theta? Whoa! Yes. So sometimes they're just going to ask you to find one of them. Okay? Sometimes they'll want you to find all 6. If I'm doing all 6, the first one I'm doing is cosecant, because it's 3 over 2. That one's easy. Yes, ma'am.
So, will you walk through how you knew it was negative because it was in quadrant 2?
This is how we started. All students take calculus. So second quadrant, sine and cosecant are the only 2 that are positive.
And why is it?
Because it's cosine, not cosecant.
Oh.
Yes. Okay. So here's cosine. Here's 1. If I wanted to know cosecant theta is 3 over 2, we're automatically there. Can I use another identity to solve that is involving our cosecant theta? We already know this one. So we've solved 2. That is a 3. We have 3 more to go. Can we do this using an identity? What's another identity that has cosecant in it? Cotangent theta plus 1 equals cosecant theta. Oh wait, I forgot all my squares. It doesn't work if it's not squared. I said I forgot all my squares. So it doesn't work if they're not squared. It wasn't a question, it was me realizing that I had forgotten the squares, and it doesn't work if it's not. So if you already know cosecant is 3 halves, can you find cotangent? See, I get ahead of myself. So if this is, actually, let's go ahead and do it, Dr. Hearns. If we want to solve for cotangent theta, it really is cosecant theta, which is 3 over 2 squared minus 1. Alright, just plugging in. I rearranged and plugged in at the same step. Are we okay with that? Yes. So this is really 9/4 minus 1. What is 9/4 minus 1? It's not, it shouldn't be negative,
5.
but it should be 5/4, correct? So cotangent, I did that. Cotangent squared is 5/4. What if I just want cotangent?
Square.
I have to take the square root. I'm thinking, is it positive or is it negative when I take square roots? What quadrant are we in? 2. Is cotangent positive or negative? Negative. So negative square root of 5 over 2 is cotangent theta. So we've solved for 3 out of the 5. Question, really quick. Could I go back and say, if I know cosine, can you find secant? If you know cotangent, can you find tangent? Okay, so let's go ahead and do that. If cotangent is square root of 5 over 2, this will be 2 divided by the square root of 5. So let's go ahead and rationalize as I'm doing that. Can we go back and say cosecant, which I probably should have done right after we did it, but I forgot. Secant theta, reciprocal, 3 divided by the square root of 5 3 on the square root of 5 over 5. So it's doing two formulas and then taking reciprocals of all your answers. Okay? I don't know which one is easier, which one is better. Some will argue this and that. Okay? You need to know another way to do it. And last, which we won't derive, are the quotient identities, which are super simple. Somebody, you've got these written down? Do you have sine and cosine written down? The two quotient identities are only for tangent and cotangent. They tell us that tangent theta is simply sine theta over cosine theta. If you really want to try it, use your y over r divided by x over r, and I promise you, you'll get out y over x, which is opposite over adjacent. And then cotangent is simply still the reciprocal of that, which is cosine theta over sine theta. Still just the reciprocal. There's one or two examples that you could do, look at. Example 6 and 7. If you find sine and tangent, if you're given cosine, okay, can you use identities to do that? Okay, we may work some more tomorrow, but I want to go ahead and give you homework tonight, so I don't give it on Wednesday night. Is that okay? All right. We're going to do from 1.4. 1.4 problems are 1, 3, 5. Really not that many. 16, 27, and 29. 31, 37, and 40. 45, 48. 61, 63, and I understand we might have to do some of these identities tomorrow. The last ones are use your identities. Try those. 69, 71, and then 93, and that's it. 6, 8, 17 problems. Not too bad. Stop.